We have shortcuts that work for triangles. So that's what we're talking about today. So we're in section 8.3. And we said yesterday that to figure out if polygons were similar, we had to make sure that all the corresponding angles were congruent and that all the corresponding sides were proportional. Well, with triangles, we can shorten our work so we don't have to check all the sides and all the angles. And it's kind of the same thing we did when we talked about congruent triangles. So let's remember really quickly. Our shortcuts for finding out if triangles were congruent. Does anybody remember our theorems, our postulates for congruent triangles? They had nice little acronyms. You remember one, Lyndon, for congruent triangles? How do we show triangles were congruent? Had to do with angles and sides? Side, side, side was one. Side, angle, side was one. Angle, side, angle was one.
It's not angle, angle, angle.
Angle, angle, angle didn't work. Well, if we have two angles, we'd have angle, side, angle. For a right triangle, we had hypotenuse, leg. So those were our ways that we could show the triangles were congruent. Well, we have, for similar triangles, we have three shortcuts that are kind of like these shortcuts. So that's what we're going to do today, is talk about those shortcuts. So the first one is, and you might have been thinking of this, Jenna. We can show that two triangles are similar by angle, angle. So angle-angle similarity says that if two angles of one triangle are congruent to two angles of another triangle, then they are similar. So our first shortcut, we don't even have to worry about the sides. If we know that two angles of one triangle are congruent to two angles of another, that guarantees us that our triangles are similar. That makes our lives a little bit easier. So let's look at a couple of examples of this. So here are my triangles. Make that one a little bigger so I can put my angles in there a little better. Alright, so there are my triangles. These are not to scale. I'm going to redraw this one because it doesn't look quite the way I want it to. Alright, so we're going to say this is a 90-degree angle. This is a 90-degree angle. That's 65. And that's 25 degrees. And we want to know, are they similar? So what are we going to have to do to decide if they're similar? We know these two angles aren't congruent. What's that? We need to find one of the missing angles and see if they match up. So I'm going to add these two. 90 plus 65 is 155. And 180 minus 155 is 25. So this missing angle is 25 degrees. So now I have two angles in this triangle congruent to two angles in that triangle. So my answer here would be yes. And we would say by angle, angle. So I found the missing angles, and I know that two of them match up. So that guarantees me that the triangles are similar. So let's look at another one. Here are my triangles for this one. And this angle is 105. That angle is 105. That's 45. And that's 47. So would these two be similar? These two aren't congruent, these two are congruent. And is this missing angle going to be 45 degrees? No. And this missing angle isn't going to be 47. So our answer here would be no. So they're not similar. We have to have two angles that match up exactly for them to be similar. Any questions on angle, angle? So with angle, angle, we don't even have to check the sides. All we need to know is that two angles are congruent. All right. Our next shortcut is side, side, side. Now for side, side, side congruence, we said that our sides had to be, all the three sides had to be congruent. A little bit different for similarity. For side, 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 we're going to say if three sides of one triangle are proportional to three sides of another, then our triangles are going to be similar. So we have to make sure our sides are proportional. Let's remember. So remember what proportional means. Anybody help us out with what we said proportional meant? Remember, Austin? So what do we do for our opener? What do we turn the sides into? Same ratio or fraction. We turned them into a fraction. So proportional means same ratio or fraction. So all three sides, all three of the corresponding sides have to have the exact same ratio. They have to make the exact same fraction. And when we say the same, if one turns out to be 2.57 and the other is 2.6, they're not exactly the same. They would all have to be 2.57. Each one of them have to come out to be exactly that. So they have to, all three ratios, when we match up the sides and make fractions out of them, they have to be exactly the same for our triangles to be similar. So let's look at a couple of examples with side, side, side. So my pictures, none of my pictures are going to be to scale. So give me a fair warning there. Go by what it looks like, or go by what it says, not what it looks like. So there are my triangles, and we want to know, are they similar? Now when we match up our sides, when we make ratios of our sides on triangles, the small side is going to match with the small side, the medium side with the medium side, and the big side with the big side. We can't just mix and match however we want. I'll make sure that small, small, medium, medium, big, big. So if I'm going to make a ratio or a fraction, and I'm going to use side length 5, which side is that going to match with on the other triangle? The match 5 is the smallest side here, so it has to match with the smallest side on that. 5 divided by 2.5 is 2. These two are the same, so we have to match those up with each other. 9 divided by 4.5 is also 2. So these triangles would be similar by side, side, side. Each side has the exact same ratio or makes the exact same fraction. Questions on that one? If I had 3 different sides, if these two weren't the same, I would have to check all 3, and all 3 would have to be exactly the same. So let's look at another example. Same question, are they similar? So here are my triangles. All right, so we need to check. We have 3 different sides. So what side is going to match up with side length 7? Is 7 the big, medium, or small side?
Medium.
Medium. So which side is the medium side here?
11. Oh, 14.
14. 7 divided by 14 is 1/2. What side is going to match with 5? 5 divided by 10 is 1/2. And then we're going to match 11 and 24. 11 divided by 24. Does that equal 1/2? No. Not equal 1/2. So this would be no. All 3 are not exactly the same, so these two are not similar. They're kind of close, but not quite. Questions on that one? So side, 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 we don't have to worry about the angles. All we have to worry about is the sides. Make sure all the sides are proportional. They make the same ratio, make the same fraction, and we're all set. That guarantees us that the triangles would be similar. All right, our last one. We just have 3 for similar triangles. Side angle side. So side angle side, again, a little bit different than when we use side angle side for congruent triangles. We're going to say if two sides of one triangle are proportional to 2 sides of another. And we have a second thing that has to happen. and the included angles are congruent, then they are similar. So we know that proportional means the same ratio or fraction. What does included mean? It's been a while since we've talked about included angles. Anybody remember what included means? In between. Included means between. So the angle has to be between the two sides that are proportional. So we're looking at two sides on one triangle that are proportional to two sides of another triangle, and the angle is between them. So let's look at some examples using side angle side. So here are my triangles. And we're going to say that this side is 14, and this is 7, and this is 10, and this is 5. So before I even put the angles in there, are these two sides proportional? Two sides on this triangle proportional to two sides on that triangle. What do I have to multiply 7 by to get 14? 2. What do I have to multiply? Actually, I mixed my sides up. I want the 10 here. This should be 5. There we go. What do I have to multiply 5 by to get 10? 2. So I multiply this by 2 to get 14, and multiply this by 2 to get 10. So the way I wrote it before, they were not proportional. You guys were right. So when I switched it around, are they proportional now? Yes, because I multiply this by the same number to get this as this. So the sides are proportional. So what would I have to know about the angles for these triangles to be similar? The angle, this angle here, and this angle here. What would I have to know to guarantee that these triangles are similar? The angles are congruent. The included angle would have to be congruent. So if this angle, I'll do it in red, if this angle were 110 degrees, then our angles are congruent. And so the answer would be yes by side angle side. If they were different at all, if this were 111 degrees and this were 112 degrees, then the angles are not congruent and the triangles are not similar. So if the included angles are the same, if they're congruent, then these triangles would be congruent because the sides are proportional and the angles are congruent. If angles are different at all, then the triangles would not be similar. Question? What's that? This angle, yes. So for side angle side, we have to have the angle that's between the two sides. That's what the included angle means. It has to be between these two sides. Now, if we knew some of the other triangles and we could figure that one out, we might be able to do it. But if we had these two sides proportional and one of these other angles congruent, we wouldn't know for sure. All right, last example. Here are my triangles. And we'll start out knowing that our angles are congruent. This side is 5, this side is 8, this side is 3, and this side is 4.8. And we want to know, are they similar? Well, we have two sides and the included angle, and we know that the angles are congruent, so we're good with the angles. We have to check the sides. So we're going to make a ratio. Which side length would match up with side 5? 3. So 5 is the smallest, so we have to match it with the smallest there. 5 divided by 3 comes out to be 1.666, and it repeats. And then I'm going to make a ratio of the other two sides. 8 divided by 4.8. And that comes out to be 1.666, So angles are congruent. The sides make the same ratio or the same fraction. So our answer would be yes by side angle side. Questions on that one? So 3 shortcuts for triangles. Angle, angle. We know two angles are congruent. Our triangles are similar. Side, side, side. If all 3 sides are proportional, make the same ratio, then our triangles, did I say congruent before? Our triangles are similar. And side, angle, side. 2 sides proportional, the included angle congruent. Are shortcuts for showing that triangles are similar. Everybody good?